Hello, 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 everybody. What a wonderful day to start another math contest. And we're going to be going through the 2001 Euclid paper. So we've already done the 2000 in a previous set of videos. We're going to move on to the 2001 Euclid paper. Because if you're interested in sort of reaching the peak of math contests while you're in high school, and if you're interested in getting, say, scholarships, perhaps to the University of Waterloo, a good idea is to write the Euclid contest and to write it well. So, going through videos like these, you can practice comparing your solutions to mine, and maybe learn some tricks and improve your techniques. So let's get to it. Let's get looking at the 2001 Euclid paper. So unlike the Pascal-Keeling and Fermat, which I've also gone through for the year 2001, we have a time limit of 2.5 hours, not just 1 hour. Okay, this contest does differ from the multiple choice ones, largely in part thanks to this sort of papery symbol here, which means you have to write out a full solution. So part of this contest is just short answer, not multiple choice, but just give us the final answer. And other parts are write down full solutions. Now, as I have with the past Euclid, and as I will with any future contest set up like this, I'll be writing out full solutions to just about everything, just so you can understand the reason, and I can talk through the question a little more, and you can see, just more practice as to what you should write when you're writing proofs. I also do that, especially in the short answer sections, because even though they're looking for just a short answer, if you don't get that answer right and you haven't written anything else, any explanation, any proof, you will get 0. Whereas if you've written something else, if you've written some justification, some proof, some explanation, you can get part marks, and part marks can sometimes make all the difference in terms of a good score. Okay. So the Euclid, broken down into short answer and full solution. We're going to be going through everything. And just in this video, we're going to do question number 1. So question number 1 has 3 parts to it, A, B, and C. A and B, we just need a final answer. C, we'll have to write out a full solution if we were doing this on an actual contest. And let's get cracking. So, 1A, what are the values of x so that 2x minus 3, all squared, is equal to 9? Okay. So this is sort of, can you do basic algebra manipulation? Can you sort of unravel what's going on the left-hand side to isolate just for x? Okay. So I notice that we do 2 times x, then we subtract off 3. First we do 2x, then we subtract off 3, and then we square everything, and that should get us 9. So we started with the x, multiplied by 2, subtract 3, and then squared. If I want to get to the x, I need to sort of unravel the equation. I need to remove everything in the reverse order we did it. So the last thing we did was squared, and we got 9. So I'm going to square root both sides, get rid of this square up here, and it'll become 2x minus 3 is equal to the square root of 9, because whatever I do to one side, I have to do to the other, and that gives me 3. So then, before I squared, the last thing I did was I subtracted off 3. So now to cancel that out, I'm going to add 3 to both sides. So I'll get 2x over here, and I will get 3 plus 3 is equal to 6. And to get x by himself, I just divide both sides by 2. And I get an answer of 3. Okay. Now one might think that we're done there, but of course we're not. We've missed something. When we took our square root, we took just sort of the square root of 9. Whereas, in fact, if we're looking for something that squares to 9, we could have had 3 or negative 3. Okay? So little checks like that. Since we have an equation in x squared, we're going to expect that there should be a couple values of x, and we only have 1. So we're going to take a look at it again and make sure that we do have all the values of x, and we don't. It should really be plus or minus 9. So we'll clean that up a little bit. So plus or minus 3. Plus or minus 3 here. So 3 plus 3, well, we got that. That was great. That was 6. But minus 3 plus 3, so that could be 6 or 0. So one of our options was x is 6 divided by 2 equals 3. But another one is x equals 0 divided by 2, which equals to 0. Okay? So the key hint there for me to go back and take a look at it again was, I have a bunch of stuff in x, and I square it. I should be expecting a couple values of x. If I were to, fourth power it, I would also expect some more values of x, that sort of thing. So, our potential answers are 3 or 0. And what we can do is we can actually double check this mentally. If we plug in 3 here, 2 times 3 is 6, minus 3 is 3, square it is 9. 2 times 0 is 0, minus 3 is negative 3, square it is 9. So our final answer is x is equal to 3 or 0. And we will put that in the box provided. Alright, so let's take a look at B part. If f of x is equal to x squared minus 3x minus 5, what are the values of k such that f at k is equal to k? Now here again, we're going to have sort of a quadratic. We're solving an equation involving a quadratic. I would expect multiple values here. So I could probably solve and find 1k, but I want all values of k. And so I should expect to have at least 2. Okay? So let's take a look here. Let's set up the equation. We want f at k is equal to k. Well, what does that mean? Well, f at k is k squared minus 3k minus 5. So we want that to be equal to k. Well, let's collect everything onto one side. We have a k over here. Let's subtract k from both sides. We get 4k. So minus 4k minus 5. And we brought this k over, so we're going to have 0 over here. And now we have a quadratic in terms of k. And you can do a couple things to solve this. You can try the quadratic formula, or you can practice factoring. So I want two numbers that multiply to negative 5. So that's either 1 and negative 5, or 5 and negative 1. And add to 4. Well, I'm going to have negative 5 and 1. And to double check that, we could really quickly sort of FOIL this out or expand this out and make sure that we do get k squared minus 4k minus 5 is equal to 0. Or if you wanted to, it always works, the quadratic formula. Quadratic formula would be an excellent thing to do here. But sometimes we can factor it and it's a little quicker. So, in order to make this 0, no two numbers multiply to 0 unless one of them is 0. So either k is equal to 5 or k is equal to negative 1. So our final answer here is going to be 5 or negative 1. And if we wanted to, we could also double check that. Plug in f at negative 1. What will we get? We get negative 1 squared, which is 1, minus negative 3. So that would be 1 plus 3 minus 5. Well, that's negative 1. 4 minus 5 is negative 1. And negative 1 is what we wanted out. So we do have f at k is equal to k. That does it for part B. Again, we got two solutions because we were working with a quadratic there. We should expect two solutions. Sometimes you'll only get one. When the resulting quadratic that we worked out in k, if that had only one root, you would only have one solution there. Okay. C part, the part we need a full solution for. Determine all coordinates x, y such that x squared plus y squared is equal to 25 and x minus y is equal to 1. So, for those of you who recognize your curves based on their equations, we have a circle here centered at 0, 0 with radius 5, and here we have a line, specifically the line y equals x minus 1. Okay? So we could draw a picture, but I really don't think we need to graph this one. I don't think it'll help us, but the idea is we have a circle, and when we draw a line through it, you can have either intersecting at 2 points, you could have something intersecting at 1 point, or you can just have it miss the circle entirely and intersect at no points. So we should get 2, 1, or 0 solutions. I'm going to expect 2 just because that's more common. I'm just a little experienced with some of these things. I will expect 2, but if I get 1, I'll double check it and make sure of that. I wouldn't expect 0 on a question like this. I'd expect them to actually have an answer. But I might be pleasantly surprised. So, we've got the equations x squared plus y squared is equal to 25. And we have x minus y is equal to 1. Well, the best way to do this is to change our line and rearrange it until we get y in terms of x or x in terms of y. Substitute that back into the equation for the circle. And then we'll have a quadratic, either in x or in y, and we can solve that. And that should give us our, say our x coordinates. And then we can use our equation from the line to get our y coordinates. So let's solve for everything in terms of x. So this line equation becomes x is equal to 1 plus y. And we're going to sub into the circle. So here we've got x, so we're substituting something in y into x. So we'll get 1 plus y squared plus y squared is equal to 25. So we'll get a quadratic in y, solve for it, and then using this, once we have our y, we add 1, and that'll give us the x coordinate. Okay? So we can expand this out using the binomial theorem, or, FOIL, that works too. So 1 plus y squared is 1 plus 2y plus y squared. We have another y squared here is equal to 25. Bringing the 25 over onto the left and grouping things together, we have 2y squared plus 2y minus 24 is equal to 0. Well, I notice I have a factor of 2 in each of these. I can divide by 2 on both sides and not really change the roots. So, dividing by 2, we just get y squared plus y minus 12 is equal to 0. And so once again, we can either choose to stop and think, and we can probably factor this just in our heads, two numbers that multiply to negative 12 and add to 1. Or, if you're not familiar with that, or you want a reliable, if a little longer, but guaranteed technique, use the quadratic formula. Use whichever one you want. Okay? I factored it mentally last time, so I think we'll use the quadratic formula. Although, just to show you how quick it is, I can already see that we're going to have plus 4 and minus 3. So negative 4 and 3 will be my roots. But let's do quadratic formula, just in case people out there want to practice that. So negative b, well, b is the coefficient of the y term here, so negative b plus or minus b squared minus 4 times a, well, a is the coefficient of y squared, so times 1, times c, which is negative 12, all over 2 times a, and once again, a is 1. So negative 1 plus or minus, we've got 1 here, plus 48, all over 2. So negative 1 plus or minus square root of 49, all over 2. So I have negative 1 plus or minus, well, what's the square root of 49? It's 7. All over 2, so we're going to have negative 1 plus 7, which is 6 over 2, so that's 3, or negative 1 minus 7, that's negative 8, divided by 2 is negative 4. So these are our y values. And x, we know, is equal to y plus 1. So for 3, we get 4. And for negative 4, we get negative 3. So, in fact, we're going to have two sets of coordinates. We're going to have 4 and 3, or negative 3, negative 4. These are going to be our coordinates. Okay. And we sort of explained what we were doing at each stage. We probably maybe could have used a little bit more explanation as to rearranging this. But I would say what we've done is fairly clear. we rearranged, we subbed into the circle, and that's really the only explanation we gave. The rest was all just math. So we got ourselves a quadratic, as we predicted. Solve for it in terms of y. You use the quadratic formula, but you could have done it either way. We got 2 possible values for y out, and then we remembered how to get x from y, and that gave us our coordinates at the end. And we can double check, are these points on the circle? Do these points satisfy this quadratic, and are these points on the same line? We can do all these checks at the end, and I really do encourage you, if you have the time, so if you've done the contest really quickly, or you've sort of reached as far as you can go, you should use your remaining time to check some of your simpler answers. Make sure you didn't make an arithmetic mistake. Make sure you read through all the questions. And got all the details that you needed to get a final answer. I know when I was first writing these, I didn't get much past question number 4 the first time I wrote a Euclid, and I had a lot of time left because I just was not getting 5, 6, 7, 8. So I tried 5 for a little bit, and I think I tried 6 as well. But at that, I was way too young, so I wrote off 7, 8, 9, and 10. Those were a lost cause to me. And so what I did is I spent the remaining time just double-checking my answer for 1, double-checking my answer for 2. Forgetting what I had done, seeing if I could just rederive the whole thing from scratch again. Not rereading my notes, but actually rewriting the whole thing out on a scrap piece of paper and making sure that my earlier arithmetic matched my later arithmetic and that I got the same answer. So even if you can only answer a couple questions, make sure you answer them well. Use your time limit. You have 2.5 hours. So if you can only do a couple questions, 2 or 3 or 4 questions, make sure you did them as good as you can, because that's still potentially 40 marks there. And that's a very good score, especially if you're a first timer. Anyways, that concludes question number 1 on the 2001 Euclid. We're going to take a look at question number 2 in the next video, and so on. And we'll get all the way to question number 10 eventually. So if you're here for that, you can skip a couple videos ahead. But yeah, I'll see you guys for question number 2 in the next video. Thanks for watching.